Hi, I'm Kent. Let's create a new plaster slit casting mold. In this video, I'm going to go from design concept and show how I use shapecast to make a new mold. What I want to do in this video is basically make a cup that is more or less like this shape here. So this is a cheap restaurant cup, and I have several of these in my cabinet, and it's time for them to be replaced with my own creations. I'm going to use this as a starting point, and I want to go ahead and make a plaster mold so I can slip cast something more or less this shape and make new ceramic pots that way. And to do that, I'm going to use Shapecast. That's the software I created that lets you basically input a simple 2D profile of your pot, and then it automatically generates all the parts needed so you can 3D print them to create a new plaster mold. So first up, we need to make a digital version of this that we can then copy. So I've got my calipers here. You could use a ruler or tape measure, and I basically want to measure the bottom diameter here, the top diameter, and the height. So this is, we'll call it 60 millimeters. The top is maybe 75. And then the height is about 130. All right, so let's jump into the computer and we can go ahead and sketch that up. So this here is Inkscape. This is what I'm going to use to go ahead and make the profile that I need for Shapecast. So I like blocking this out with a bunch of rectangles. So this here is the rectangle tool. So let's go ahead and draw a rectangle. And then up here we can set the width and height. Notice my document's already set in millimeters. Shapecast needs millimeters. We said the bottom diameter is 60, so we need the radius for Shapecast since we're doing the profile. So we need 30 here. And then the height was 130. Make this a little bit easier to see. All right, and then I like to go ahead and put this at the origin. So x is 0, y is 0. All right, so this here is basically the bottom radius of our pot. So we'll go ahead and make another one. Same thing. We want the height of 130. All right, and then our diameter was 75, so our radius needs to be half of that. So that's 37.5. Like that. Only one of the changes I want to make is I actually want to flare the top out a little bit more. So I basically want to make it another centimeter wider. So let's go ahead and make this 42.5. Here we go, and again, put it at the origin. All right, so this is kind of blocking out the pot, so we're going to go from here to here to here, and that would be the plastic cup that we have with the slight modification that it's wider. And then I also want to put in a foot, so we'll draw another rectangle down here. I think I want to make it 2 millimeters tall. And the width doesn't really matter. Now this up here is the snapping tool, so now we can move this so that's aligned with the bottom corner. Probably have to zoom in a little bit more. All right, then it snaps the corner there. So this here is actually going to be the inner point, and then we're going to come down to here. The other thing is I want an area for glaze to stop. So let's draw a line, and I want this to be, so if I use control, I can snap the angle. I want it to be 45, and I want the distance to be 5 millimeters. Or really close. 5.1, that's good. All right, so we have this line here. And again, I want to snap this to this line here. Okay, perfect. So all these lines are a little bit thick to see, so let's make them a little bit thinner. So now we're going to go ahead and draw the pot profile. This is basically just sketching out what we need. So we're going to start here. And I'm going to go down to this corner here, then up to here, and then finally all the way up to the top corner. Push enter. Let's go ahead and make this black. Make it a little bit thicker. So this here in black is basically what we're going to use as the pot profile, only I don't want it so angular. I want it to be a little bit curved. So we can go in here and use the node tool here. And go down to the foot and turn off snapping. So if I select the line here, now I can curve it around a little bit. So now the foot has a little bit of a swoop to it. This part here I want to curve in just a little bit. And then I want a little bit of curve to this line here too. There we go, something like that. So what I recommend at this point is go ahead and saving a copy and then deleting everything except for the pot profile. This will fail if you put it in the shapecast. Shapecast only expects one line. It doesn't know which one is the pot. All right, and there's the profile of the pot. All right, so we'll save this and we'll upload it to shapecast. So go to create, we'll choose the SVG file. There's the preview of our pot. And then you can click continue and select your clay shrinkage. If you need instructions, here are instructions on how to calculate that. And the outer part mold, we're going to do a 2-part mold. So we'll submit it for processing. We'll go to designs, and I already did one ahead of time. So that creates a bunch of STL files. So there's the inner mold, which is this one here. It's basically the profile we drew. And then the outer mold, which will be used to contain the plaster. And so with these files, now you can go ahead and use your 3D printer to print these up. The first thing that Shapecast does is it creates a design proof, and this is that's been printed out. And the idea is that you can print this out, the walls are relatively thin, so you can get a sense of what the form is. So did I measure everything correctly? So the bottom diameter is at the right size. Did I get the top bigger like I wanted? I added those curves. Do I like the feel of those curves? Things like that. So basically this is just checking to go ahead and make sure you like everything before you invest in going ahead and printing everything else out. I did exactly that. I printed this out, I liked it, so I went ahead and then printed out the rest of the pieces. And so here's the full mold system. So this here is the most critical part. This is the shape of our pot, only it's been scaled up to account for clay shrinkage. So you'll notice that it's bigger. My clay shrinks by 13%, and that's what I selected. It's also added an area for the slip well, and you'll notice this is upside down. It's because we're going to pour the plaster upside down. Eventually we'll flip this over to slip cast it. I printed this on a relatively fine 3D printing settings, basically very small layer height. There's a little bit of surface texture in here, but basically very little. It's a little bit more noticeable in the top, and then there's a seam line here. So there you can see there's a little bit in the top that will come through and transfer through, and here's the seam line. You might be able to see that, but the layer lines themselves, they're pretty good. This is the outer mold to contain the plaster. This is basically replacing a bucket or cottle boards, and they are specifically shaped so that you basically have about a 1 inch or 25 millimeter thick plaster walls. These are also straight off the printer, and they'll get assembled like that with the inner mold inside. And of course this doesn't have a bottom, and that's what these are for. So what we'll actually do is we'll put these together. This will go on here, and this will go like that. So that's how we'll use the mold, and then plaster will come in here. We'll disassemble it, and we'll have a new plaster mold. However, we need to do a few more steps before then. One of the things I'll note is in 3D printing these outside pieces should be able to be printed without support. They basically have a shallow enough angle that they should do pretty well. Even this top overhang, if it's really steep, you might need supports just right here. But I printed these without any supports at all. The inner mold needs supports. So here I'm using the organic tree supports, and this is basically just as it came off the printer. You can pull these out. However, you don't need to because it's the inside of the mold. I'm actually going to use them in just a few minutes here because they will come in handy to hold on to this. So back to prepping the mold. So we need to do a couple of things. One, since I chose a 2-part mold, I need to go ahead and glue this ring together to be one piece. So I want to go ahead and line that, and I'll just use some super glue, some CA glue to put it together. There are a bunch of holes in here that I can put heat set inserts into. I'm going to use that to attach the pieces together. And then there's a little groove here, a little recess that I'll use a foam gasket to seal this up so that it doesn't leak. So that'll be the mold assembly. The other thing I want to do is go ahead and smooth this out. I think the layer lines are okay, but this bottom needs some attention, and so does the seam. I'm going to go ahead and use this primer here. It's a filler primer. Basically, it's thicker than most primers, and it's designed to go ahead and fill imperfections. Basically, I'll put on a coat of this, lightly sand it, make it smooth. I'll put on another coat, sand it again. I'll do that 2 or 3 times so that this winds up being a nice smooth finish. If you want, you can use this straight off the printer, as long as you don't mind these 3D printed artifacts, or you can post-process it using primer or some other type of filler material. Let me go ahead and put a coat of paint on, and while that's drying, we can go ahead and insert the heat set inserts into the mold and glue the bottom ring together. Here's the first coat. I went ahead and coated basically all the surfaces that are the pot themselves. I didn't worry about the slip well. And you can still see some of the layer lines. So it's going to take a few coats to build that up, and some sanding as well. And there's the seam line. You can see a few of the layer lines. I'll probably go ahead and sand those as well, just to try and get it as good as I can get it. All right, so this needs to dry. And I'll do several more coats off camera. All right, next up is the ring, and I just want to CA glue this together. Let's put some CA glue here on the edge. I need a piece of paper here because I don't want to glue this down to my bench. Let's go ahead, push it together. Make sure it's aligned, because otherwise we'll have problems. Looks pretty good. We got some activator here. Go ahead and put some more on. Make sure this is nice and plaster tight. The reason this is in multiple pieces is so that you don't get too big relative to your print bed size. This one I probably could have made in one piece, but right now I don't have that as an option in Shapecast. The outer walls definitely need to be in at least 2 pieces so they can be disassembled from around the plaster. And I want the holes to line up, which is why I went ahead and made the rings the exact same. All right, we'll flip it over and get the back side. All right, we'll go ahead and let that set up. Again, this doesn't need to be pretty, it's really just to hold the plaster. All right, so next up are the heat set threaded inserts, which are these guys right here. So these are little brass pieces that are threaded on the inside. And what we'll do is we'll heat them up, and there's 2 sizes of holes. One's larger, that's for the threaded insert, and the other one's smaller for our bolt. We'll basically heat it up and push this in, and that will let us bolt the 2 halves together and bolt the bottom ring on as well. So I've pulled up my soldering iron. It's set at a relatively low temperature. It looks like around 225°C. Basically, you just want something hot enough so that it will start to melt the PLA, but not too hot that it burns it. There are special tools you can use to heat set the inserts. I haven't bothered. I have a relatively fancy soldering iron. You don't need one of those either. You can use just a cheap soldering iron. That would work just fine. So basically, let's take the soldering iron, put it in place. Let's put a little bit of downward pressure. And try and get it straight, and it will sink in. Just want it below the surface, just like that. Grab another one. Do the same thing, just like that, and fill up all the holes. All right, so there's the first one, basically down one side and across the bottom, and that took me 3 minutes, so not very long. I'm going to go ahead and do the same for this one. All right, and there's the second piece, just like that. The nice thing about using the threaded inserts is it means that the PLA mold can be reused to make several plaster copies, so you don't need to invest in silicone. You can basically directly reuse this. I have been thinking about other ways to attach this. It occurred to me that you could probably get a longer bolt and use a nut on the backside and maybe a washer, so you might not need to heat set those. I haven't tried that, but I'm pretty sure it would work. All right, next up is this here, which is a neoprene gasket. So it's got neoprene with an adhesive on the backside. And this is what will help prevent plaster disasters. We'll use this so that the mold becomes plaster tight when it's liquid. And there's a little groove here, a little recess, and that is so we have space for the gasket itself. So we're basically going to run a piece down along here, across the bottom, and up the sides for both of these. And we'll run some around here and run some around here. And this little ridge that is left, this is actually the mating face, so you want to make sure the gasket's held back so it doesn't get squished into this hole here. So there's no recess here on the bottom. All of the recess is in the bottom ring. And so we can print this flat on the bed. But same thing, you want to hold the gasket back. Basically center it over the holes here where the inserts are. And run it continuous around the corner, that way there's not a spot to leak, or the spot to leak is really small. Up over the edge. And just use an old pair of scissors and snip it off. And we can trim that and just wrap it around, doesn't really matter. Press it down nice and tight. It'll get squeezed between the pieces, but you don't want it to fall off. All right, one piece. If you're wondering about the gasket, I did try not using it. I have a bunch of videos when I was developing Shapecast where I was experimenting with a bunch of different things, and the plaster would leak. Basically, the 3D printed faces are not flat enough to really mate and create a watertight seal. And likewise with the threaded inserts, I probably have more than I need, but I'd rather no plaster disasters. Better spend a few minutes up front than an hour later cleaning. So these will go together like that. So we got a gasket on both sides. And I like to overlap this just a bit. So there's no spot there. All right, and that's the gasket all prepped. So I need to put a few more coats of primer on and sand it so I can get out these layer lines. And the reason I left the supports in is so I can hold on to it. But what we'll wind up doing in just a few minutes for you, it'll be a little while for me because I need to wait for the paint to dry, is we'll put that on the inside, around, and around. Then all these holes here we'll use for bolts, just like these, and we'll zip it together so that it gets nice and structurally secure and plaster tight. So off camera, let me go ahead and put a few more coats on this so we can get it nice and smooth. All right, it's several hours later, and I went ahead and put on several coats and sanded it back, and it's looking pretty good. Top here is nice and smooth, and the seam line can't really make out anymore. I went ahead and sanded it back with some 220 sandpaper and then used some Scotch-Brite, smooth it out, and then I put another light coat on. So at this point we can go ahead and take the supports out. And I just realized I forgot to put the threaded inserts into this piece here since I was painting it, so let me go ahead and do that real quick. All right, there we go. Now we have them all. All right, now we can screw the ring on. And I put it on a piece of paper here just so I don't mar up this finish here, since that's going to be our pot. And I marked a couple of the bolt holes, since otherwise I'm drilling blind to start with. So let's use the driver here that I have, and some bolts. And you just want to snug these down. It's really easy to sink them too far into the PLA. You could put a washer on here, but I haven't found it necessary. So once they're started, it's pretty easy just to go and put the rest in. And you can definitely feel them bite into the threaded insert. All right, there we go. So there's the inner mold connected to the bottom ring, which is the bottom of the plaster pour. Now for these, I like to go ahead and put them together. One in the middle. And then one on both ends, make sure they're aligned. Same for the other side. All right, there we go. All the bolts are in. So now we should have a plaster tight seal. So let's go ahead and mix up the plaster. Since Shapecast generates all of these models from the profile, it also knows how much plaster we're going to need. So it calculates that volume. So it says 1.62 liters. That's basically the interior volume here where we're going to put plaster. And then it goes ahead and rounds that up. So we have a little bit of extra. So 1.75 kilograms. And it also calculates the water using a 70 to 100 ratio. So we need 1.22 liters of water. I went ahead and measured those out. Here's the plaster, and here's the water. So what we're going to do is we're going to take the dry plaster and sprinkle it onto the water and let it slake. I like to let mine slake for 3.5 minutes, and then we'll mix it for 4 minutes, and then we'll go ahead and pour it into the mold. And I've got my mixing attachment for plaster all set up, so let's go ahead and do it. So I think the idea behind the slaking time is we'll go ahead and let all the plaster fully hydrate. So let this sit for 3.5 minutes. Okay, this is done slaking, so now we want to mix it. We want to mix it as vigorously as possible without introducing air bubbles, which is a bit of a trick. 4 minutes. All right, there's 4 minutes. And you'll also put a board underneath to help catch any messes. And carefully pour it in. Just about to the top, a little bit below. And we have just a little bit extra, just like we planned. Let's see if we can shake bubbles free. All right, I'm going to do that a little bit more, and then we'll go ahead and let it set up, and we'll be back in about half an hour or so. The plaster has cured and is cooling down. I checked it at about half an hour and it's still pretty warm, so it's been maybe an hour now, so it's cooled down. And the plaster in the bucket's all set. So I'll just break this out later. And for the mold, we just take out the bolts now. All right, there we go. So just like that, there's the outer mold. It's looking in pretty good shape. So now the trick is usually pulling out the inner mold, but a while ago I found the trick of using a water and isopropyl alcohol mix that's been frozen. And that's this right here. So basically this has enough isopropyl alcohol in it so that at freezer temperatures it's still liquid, and we pour it in. And so what happens now is that the PLA basically is shrinking a little bit from the cold. And give it a minute and it'll just pop right out, just like that. Let's take this and dump it in a bucket. All right, this can be frozen again. And we're done with the 3D printed mold. This can be cleaned up and reused. And now we have a brand new plaster mold, just like that. I don't see any bubbles. We got a little bit of chip out here on the rim, but overall it's looking pretty good. So usually while this is still pretty soft, I like to go ahead and clean it up a little bit more. Basically just clean up the seam here with an old putty knife. Just kind of scrape it down, clean it up. All right, just like that, one new mold. So this is obviously still damp and still curing, so it'll get harder as it gets drier. So let's go ahead and let this dry all the way out, and then we can try it out. In the meantime, I'm going to clean up the rest of my plaster mess. All right, it's a few days later, and the mold is fully cured and dry. Let's go ahead and slip cast its first pot. One of the comments I often get in my videos is basically how long do I let the slip sit? And the answer is it really depends, which I know is not a very satisfactory answer. Basically, for any new mold you have, you need to experiment. If the pot is too thin, you need to let the slip sit longer. If it's too thick, let it sit less. For my pots, I usually let it sit for about half an hour. Of course, the confound there is it also depends upon your slip and the ambient weather as well. When it's hot here, it will go faster and the walls will be a little quicker, and when it's damp, it will go slower. The nice thing is if the pot doesn't actually work out, just throw it in the reclaim and you can turn it back into a slip again. No big deal. All right, so I went ahead and mixed up my slips. Let's go ahead and fill this up. So here's my slip bucket. I've got a rain barrel spigot on it. This works pretty well, although it's getting a little bit clogged. I think I'll need a bigger diameter spigot, but for right now, good enough. So I'll open it up. And I'll get to the top, and then we'll fill up the slip well as well. This is basically a reservoir, so as the slip water gets absorbed into the plaster, the slip level will drop, and that way we stay above the rim of the pot. Maybe a touch too full, but I didn't spill over the top too much, so we're good. All right, let's check back in a little bit and we'll dump out the slip. All right, let's dump this out and drain it. All right, there we go. Now I'll just turn it upside down here and let it drain. And I also let it drain for about half an hour. So we'll check back then, we'll trim the rim and see if we can pop it out. All right, let's demold it. Looks good. Now, like using a razor blade, basically go down to the slip well shelf. And just like that, more reclaim. And I like using a small piece of cardboard that's cut kind of sort of circular to help catch. So just put it there. And it slides straight out. So I don't really want to handle it, but There's the foot, so all those layer lines are gone. It's a nice bevel. It's a very slight swoop. I'll go ahead and transfer this over to a wear board and let it dry out. And then I'll clean it up just like any other pot. So there we go, just like that. We went from an idea, we sketched that up and then printed out the design proof. That looked good. We then went ahead and printed out all the mold pieces. We sanded it to get a nice smooth finish. You could use it straight off the printer if you wanted. We poured plaster and then we slip cast our pot. And you can do the same thing, basically going from idea to slip cast pot using shape cast as well. How long did this take? In wall clock time, it took several days to go ahead and do this, but like many things in pottery, there's a bunch of waiting around. So for instance, printing out the design proof and then the molds for the 3D printer, this was about 24 hours of printing on the printer. However, I just had to push go and periodically pull the print off and start the next one, so that was relatively straightforward. You saw me sketch up the pot itself, that was relatively quick. I'd already been thinking about what I wanted, so that was maybe a little bit of cheating, but it doesn't take very long to draw something that winds up being, I'd say, pretty compelling. Obviously, you can spend a lot more time if you want to. Assembling the mold goes relatively quickly. It's a little bit of work, but not crazy, and I think way easier than messing around with cottle boards or some other thing like that. Pouring the plaster, again, you need to mix the plaster, pour it, and then most of the time is waiting for it to cure, and then we're slip casting pots. So with a few hours of real work, you can go ahead and create a completely new form that is exactly yours and what you want. There is a link for Shapecast down in the description, and if you have any questions or comments, let me know. Thanks.